Okay, question 11 then. A sample of N2O5 is known to contain 4.3 times 10 to the 24th molecules. How many nitrogen atoms are in this sample? Let's see if we can shrink this down a little bit and maybe work on this while we still look at that problem. So let's get rid of these guys. So in this problem we have our sample contains, so it is N2O5, N2O5, and it contains 4.3 times 10 to the 24th of those molecules of N2O5. So that's what I'm given. And what I want over here, in this case, is atoms of N. And I'm given 4.3 times 10 to the 24th, and that is molecules, N2O5. So I'm going to multiply so that I put molecules, N2O5 on the bottom, and I'll put atoms of N on top. And let's just look at a representation of this. N, O, 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 O. So every time I have one of these molecules, so for every one molecule of N2O5, how many atoms of, in this case, N do I have? Well, I have 1 and 2. So I'm going to put a 2 there, cancel those units, and it tells me how many atoms of N I have. Could have asked that for atoms of O per molecule. Right? In this case, it would be for every one molecule of N2O5, I have 1, 2, 3, 4, 5. So we take that molecular hammer, we hit it, we smash it into pieces. Every time we have one molecule, we get out 5 atoms. If we would have had 1 mole of molecules of N2O5, I would get out 5 moles of atom, 2 moles of atom for every 1 mole of N2O5. And that's how you do that kind of problem. Now question 12. What is the formula weight for iron oxide? So here's one where you're not given the formula, you're told it is iron 3 and it is oxide. So that's the first order of business, to figure out what the formula is. And it's iron 3 oxide. So we have iron 3 plus, and that's in combination with O. And if we look at the periodic table, that's group 6. 6 minus 8, that has a charge of 2 minus. So the formula has to be by doing the cross Fe2O3. And that works because, remember, 2 minus times 3 equals 6 minus. And this is 2 plus times, I'm sorry, it's 3 plus times 2 is 6 plus, and it counts. Now to find the molecular weight, or the formula weight in this case, it's an ion. We're going to take 2 times the atomic weight of iron, and we're going to add that to 3 times the atomic weight of O. Now we know O is, it's going to be 3 times 16.00 grams per mole, and iron, it's going to be 2 times whatever that atomic weight. You have to look that up on the periodic table. So to pull the periodic table up, there's iron, and what you see that it is 55.845. So going back, we put in right here the 55 point, I think I said 485 grams per mole. And then we add those together, and that's our atomic mass.